In this next problem, we've been asked to calculate the mass of a ballast block that's used in a tower crane and the weight of a ballast block used in a tower crane. So a tower crane is one of these cranes that you see on building sites for high-rise buildings. The ballast blocks are the concrete blocks you see hanging off the back of those. And so in our case, we've just got a ballast block that's a cuboid, and it's 2 meters by 2 meters by 500 mil. So first thing is just to draw a quick sketch. It's useful for just getting an idea in your head of the scale of this thing so that you can check that your answer is looking sensible. Okay, so I've done a quick sketch earlier. So we'll think ahead. Got to try and figure out the formula. If you can't remember it, you can just think to yourself, well, density is given in kilograms per meter cubed or tons per meter cubed. So it must be a mass over a volume. And so density is equal to mass over volume. We want to try and calculate the mass. So we just times both sides by volume. And therefore we're going to get, these ones will cancel out obviously. So mass is just going to be density times volume. So mass is density times volume. So the first thing we're going to have to figure out is what's the volume. Okay, so volume is equal to length times width times height. In our case, length is 2 meters. The width is 500 millimeters, but we want consistent units. So we're going to change that to 0.5 meters. And its height is 2 meters. And that's just equal to 2 times a half 1 times 2 is 2 meters cubed. Then we're going to use our formula. So mass is just equal to density times volume. Let's just write down what we know first. So we know that the volume is equal to 2 meters cubed. The density for concrete is one of those ones you should probably remember. It's 2,400 kilograms, approximately kilograms per meter cubed. In our case, it's a pretty big block, so we might be better to write that in terms of tons. So it'd be 2.4 tons per meter cubed. Stick the values in, so you're going to get 2.4 tons per meter cubed times 2 meters cubed, which is going to be 4.8 tons. And if you think about the size of that block, it's roughly, well, it is 2 meters cubed, 4.8 tons. Looks sensible. Happy with that answer. And then we'll just write out the answer for the person looking at your calcs, or in this case, for me, checking your calcs. And so mass of ballast block equals 4.8 tons. For part B, we're asked to calculate the weight of this block. And what I'll do is I'll just calculate that as if we hadn't already completed this question up here, and we'll just calculate it using unit weight. So the formula for unit weight, you can think of unit weight as being just like density, but you've converted the mass to a weight. So kilograms have been changed to newtons, or maybe tons have been changed to kilonewtons. And so your weight is going to be equal to unit weight times your volume. So we know when we're calculating weights, we know that weight is equal to mass times gravity. By the same token, you're going to have unit weight is equal to density times acceleration due to gravity. So if we want to know, so usually when I'm remembering these I'll usually remember the density and just figure out the unit weight. So I usually remember the density of concrete is 2.4 tons per meter cubed. If I want to figure out the unit weight, if we're working with approximate answers, we can just say, look, gravity is about 10. So therefore, you're going to have unit weight is approximately 10 times, my unit weight is equal to 2.4 tons. 2.4 tons per meter cubed times gravity is 10, so it's going to be 24 kilonewtons per meter cubed. So now we're just going back to here. So we know gamma is equal to 24. So the unit weight is 24 kilonewtons per meter cubed. And we know our volume is 2 meters cubed. And so our weight is equal to unit weight times volume. So it's 24 kilonewtons per meter cubed times 2 meters cubed, which is equal to 48. We've calculated our weight, so it must be in kilonewtons. And so weight of block is going to be equal to 48 kilonewtons. And of course, we could have calculated this directly. So you remember, if you're converting a mass to a weight, roughly you're just timesing by 10. So if you do kilograms to weight, you're going to get 1 kilograms equal to 10 newtons. Or if you're doing tons, 1 ton is equal to 10 kilonewtons. And we can see here that we've just got 4.8 tons, which is equivalent to 48 kilonewtons. So that's one done. Let's move on to the next one.